Welcome to the first video of Chapter 7. Today we're going to be doing Section 7.1 titled Nth Roots and Rational Exponents. So our goal for today is to be able to evaluate nth roots. So we'll define what nth roots are, and we will do some practice problems and figure out how to use these and see how they tie into rational exponents. So in this section we're going to expand the concept of square roots to other types of roots. So we know that 2 is the cube root of 8 because 2 times 2 times 2 equals 8. 2 multiplied by itself 3 times will give us 8. Now we know that 3 is the fourth root of 81 because 3 times itself 4 times gives us 81, right? Because 9 times 9 is 81. So what we're going to learn in this section is that for any nth root of any number, it's the same as writing that as that number raised to the 1 over whatever nth root that is. So you could actually write the square root as the second root, but we just call them square roots. So writing the square root of 4 is the same as writing 4 raised to the 1/2. And try that out on your calculator and you'll see that if you do 4 raised to the 1/2, you will get 2. And this works for cube roots as well. So if I wanted to express the cube root, I'd write my radical sign, and let's say I want to find the cube root of 8. Well, if I go into my calculator and I write 8 to the 1/3, I will get 2 as well. And this works for anything. It works for fourth roots. If we wanted the fourth root of 81, we would express that as 81 raised to the 1/4, and we would get 3. Okay, so let's find the nth roots. So what this statement is saying here is that I want you to find the nth root, meaning the third root of negative 125. So I'm just going to use this format right here to solve this. So my n is going to equal 3, and my a is going to be negative 125. So another way to rewrite this is negative 125 raised to the 1/3. Now I can do this on my calculator, and if I do that, I see that I will get negative 5. So you should definitely have your calculators out while watching this video so you can practice some of these. Okay, so let's try this one here. So same idea. We're taking the fourth root, since n is 4, of 16, which is the same as 16 raised to the 1/4. So we know that 2 times 2 times 2 times 2 would be 4 times 4, which is 16. So we know the fourth root of 16 is just 2. Plus or minus 2, because minus 2 works same way. So what happens when that exponent that we're raising our number to is not a whole number? Well, in that case, if we end up with a fraction, we have to break it up. So for this example here, if we have a raised to the m over n, what we want to do is move the m to the outside, so we're left with the n. Then we deal with it the same way we deal with the previous ones, and we have our m on the outside. So let's try out this example right here. So if I have 16 raised to the 5 over 2, that's the same as saying 16 to the 1/2 raised to the 5th. Now we know 16 to the 1/2 just means the square root of 16. And we know 4 times 4 gives us 16. So we end up with 4 raised to the 5th. And we know 4 raised to the 5th, we can punch into our calculators. We know we get 1024. Okay, so now let's look at an example of when this is negative. So we'll tie these two ideas together right here. So if, like you know from the previous section, anything raised to a negative exponent, we put 1 over whatever that is. So if we have 16 raised to negative 3/4, first thing we're going to write is 1 over 16 to the 3/4. Now, similarly, we take that top numerator, put it outside of it, and just deal with the denominator. So we have 1 over 16 to the 1/4 raised to the third. Now we know the fourth root of 16 is just 2. And we still have the third. So 2 to the third is 8. Okay. Okay, so now pause the video and practice these two problems. And then when you come back, I'll show you the answers for these. Okay, so if we have 64, trying to find the cube root of 64, we can rewrite that as 64 raised to the 1/3, and we know that that is just 4. Now, if we work on D, we have this negative on the outside, so that's going to become negative 25, and we have our negative exponent. So it's 1 over 25 to the 3/2. So we still have our negative value on the outside, and we have 1 over 25 to the 1/2 cubed. 25 to the 1/2 just means the square root of 25, which is 5. So I'm actually just going to rewrite this right here. We have negative 1 over the square root of 25, which is 5 cubed. And we know that 5 cubed is going to be 125. So this is our final answer. Okay, now some of these won't work out to be perfectly, but we still want to use our calculator to solve one of these. So this may not be clear, so let me rewrite this. So if I am finding the cube root of 3 to the 4th, I could rewrite that as 3 to the 4th times 1/3, because I'm taking the cube root of it. So that's the same as writing 3 to the 4 over 3. And if we punch that into our calculators, we see that we get about 4.3. So sometimes you need to use your calculators to solve some of these. Okay, so now getting into solving equations. So this will be helpful now because in the past we've just been used to things like x squared equals 4, and we take the square root of both sides. But now we're involving different roots, so we have to learn how to do this differently. So for this first one, we have 6x to the 4th equals 3,750. So the first thing we want to do is to isolate x. So we divide both sides by 6, and we're left with x to the 4th equals 625. Now what we want to do here, we want to take the 4th root of both sides. We're used to taking the square root of both sides, but now, since we're dealing with x to the 4th, we got to get rid of this. So now we have x alone on the left side, but now we need to take the 4th root of 625. And since it's raised to the 4th, there's a plus or minus. There's no plus or minus if this number is odd, but if it's even, we have to do plus or minus. So now we have 625 raised to the 1/4. So if we go into our calculators and write raised to the 1/4, we get x equals plus or minus 5. Okay? Alright, let's try out one more. So sometimes we won't get perfect numbers. So for this one, we have our x minus 2 cubed equals 10. I want to isolate the x, so I take the cube root of both sides. When I do that, I get rid of the cube on this side. I have x equals 2. Now I have 10 to the 1/3. Now 10 to the 1/3 does not have a perfect cube root, so I'm going to get a decimal, and that's fine. I end up with 2.15. So x minus 2 equals 2.15. Add 2 to both sides, and I get x equals 4.15. Alright, and that is the conclusion of our video. This is not your homework. You do not need to do this. All you're expected to do is take notes on the problems that I did and bring those to class the next day. Alright, thank you very much, and I look forward to seeing you tomorrow. Bye.